2, solving linear systems algebraically. We're on math now. Your notes are a little out of order. It talks about doing the substitution method first. We're actually going to do what's called the transitive property first. Solve a linear system using the transitive property. I doubt you know what the transitive property is. Does anybody know what it is? Okay, so what is the transitive property? Transitive property states that if two or more things are equal to the same thing, then they must equal each other. It's that simple. So let's just pretend that Austin weighs 210 pounds, which means he weighs the same thing as me. And let's just pretend Fat Thor weighs 210 pounds. What's true about Fat Thor and Austin? They weigh the same because they were both equal to who? Me. That's transitive property. Sorry, Chris.
Okay, for the record, he weighs one.
I know he does. I said pretend. I know he does. He weighs more than all of us.
Yeah, true. That's true.
How much do y'all weigh?
I weigh 230. Well, 225 because instead of eating 6,000 calories, I ate 4,500 for 2 days over the weekend and lost 5 pounds.
It's called water weight.
I weigh
I drank
I weigh 220.
I drank 2 gallons of water. Over.
Anyways, write transitive property down so we can do some algebra. Chris, you were asking how to solve something algebraically. I noticed that these two expressions of x, negative quarter of x plus 3 and 5/7 of x minus 9 quarters are both equal to what? So they're both equal to the same thing. What must be true of them? That's transitive property. They must equal to each other. Negative 1/4 of x plus 3 must equal 5/7 of x minus 9 quarters. This is an ugly problem because I wanted to go over fractions.
What's 28 times 3?
Why are you doing 28 times 3? Oh, okay, because you have to do what, 20 times 3.
60.
What, 3 times 8?
24. 84.
Now, Chris was asking me how to do something here. He mentioned the number 28. Why did he mention number 28? LCD. Smallest thing, 4 and 7 enter is 28. So what you do is you 28 each individual piece. You need to write it to see it. That's I don't need pen at one point in time. You got it all over your hand. Did you drain it? Fractions are not as bad as you guys think they are, especially multiplication. The first one is 28 times negative 1 over 4. Just focus on division. What's 28 over 4? 7. Times the negative 1, it's still there. Negative 7x. This is what I was helping Chris with, 28 times 3. 20 times 3 is 60. 8 times 3 is 24. What's the sum? 84. Equal because there's an equal. 28 over 7, what is that? 4. There's a 5 already there. 4 times 5? 20. Minus because there's a minus. 28 times 9 quarters, 28 over 4 times 9. No more fractions. Which way do you want to move your x's, left or right? God, y'all like left. Why do you like left so much? You guys would treat algebra like you treat relationships. Go both ways with it. It'd be a lot easier. Why don't you just add 7 to 20?
Right.
Yeah, because 20's on the right.
Because that's on the right weird.
Yeah, that's true.
If you shift your x's right, where are you going to shift your numbers? Left. Instead of taking away 84 from negative 63, which is kind of difficult, you're adding 63 to positive 64, which is not so difficult.
64 and 84.
That's an 84, that's a 63. 147. It's a lot easier if you move things around the sides you're not all that comfortable with. You don't have to worry about subtraction, you can start doing lots of addition. What are you gonna divide by?
27.
27. I guess it's not that hard when you're used to punching buttons on a calculator though. But I actually do everything so I can do it mentally. You do. 27, what's it divisible by? 9 and 3, what's 27 divided by 3? 9. 27 was divisible by 3, and I said it was. I'm betting 147 is too. 3 times 50.
150.
Awfully close.
So it's 49.
So it's 49. You guys were taught that once upon a time, find your close multiples. Work backwards. 49 ninths, which does not reduce any further. All right, so that was your transitive property example. That's how you solve when both equations are equal to what?
Each side.
Y, right? Each other.
So how does that help whenever you're checking a graph?
Because that's how you do the algebra. It says check algebraically, right?
Yeah.
That means do the algebra. So if you do the algebra, shouldn't you get the same thing? X, and then you could plug it in and get Y?
Okay.
Just do the
So if
algebra.
you plug in 49 nines for X,
You'll get Y back.
whatever you want.
All right, here's the next thing you note. Solve the linear system below using the substitution method. That's written out in the first slide, actually, what you're supposed to do. But I got a little box there for you to write in. What? Solve using the substitution method. Solve one of the equations for a variable. PS, pick the easiest variable to solve for. What's PS stand for? Postscript.
I just always thought it was plus.
No, it's postscript. It's probably the only thing you'll learn today.
Yeah, but hold on.
Yes, plus makes sense, but it's postscript.
I didn't know that.
Well, now you do.
All
All right.
I actually did learn something in that class.
And you will remember doing this lesson from Garner's room. A lot of kids don't understand which equation you're supposed to solve or which variable you're supposed to do. If you solve the top equation for x, would you have fractions?
Yeah.
If you solve the top equation for y, would you have fractions? Yeah. If you solve the second equation for y, would you have fractions? If you solve the second equation for y, would there be fractions?
No.
For y. Yes, because you'd have to divide by what, 3? Avoid fractions. What could you solve the second equation for that wouldn't have fractions? Solve that thing for x. That's what I would do. So we're going to solve x plus 3y equals 3 for x. That's a one-step thing. What do you want to do with your 3y? Just move it. I actually think you'll get more comfortable with algebra when you quit worrying about the whole add subtract thing and just moving stuff around. What happens to a sign if you jump equality? Changes. Just move things around. So now I know that x is 3 minus 3y, and I happen to notice that top equation has x. What can I replace it with? There you go. Twice a 3 minus a 3y. That's fine. Why did I write it 3 minus 3y? Because honestly, it looks better than negative 3y plus 3. It's one less sign I got to write down, isn't it? I did it that way because I'm lazy, Chris. I saved myself from typing out a negative symbol and a plus symbol. What is twice 3 minus 3y asking you to do to it? Distribute 6 minus 6y plus 5y is negative 5. What would y'all like to do next?
Put those together.
I think that'll give you a negative y plus a 6 is a negative 5. And what do you want to do with your 6?
Subtract it.
So negative y is now negative 11. There, not by 11, by negative 1. There's your y value. And Jordan, you have y. How do you find x? Oh,
You gotta plug the.
Mackie says plug it back in. I heard a kid call you Mackie. Mackay says plug it back in. You've got this nice little equation right here that's the work's almost all done for you, isn't it? That's what I'd use. 3 minus 3 11ths, that is 3 minus 33. So what's your x value? Negative 30. All right, so here's my ordered pair. My ordered pair is negative 30, comma 11. You want to do that one with the transitive property? Oh, you can do it with the transitive property. But what would you have to solve each equation for? Or x? The substitution method is the longest one of them all. Quickest elimination. You should be asking, why did he make me do an ordered pair? I don't know if you did this IXL lesson or not. It was E2. What's it asking for at the bottom? The ordered pair. Systems are always done with an ordered pair as an answer, unless somebody specifically says what is the x value or what is the y value. You guys understand that? That's why I'm doing it. Hopefully you did this lesson yesterday. Oh, everything's now hosted on YouTube, by the way, instead of the classroom, so I can see how many views I have. Not many. No. Not many. No, you got to get into the millions where you get money.
I mean, you're close to it.
Yeah, one.
Hey, all you got to I mean, he's close to it.
All right, here's your U try. You can also add subtitles now. It's on YouTube, so if you want to, watch it muted, they're available now.
Here's small, we can be active.
YouTube will process subtitles. It actually understands.
I'd be shocked, unlike some of you.
Those of you who are not doing anything, solve the second equation for x. Solve the second equation for x. No, it would be negative 5 on x. Correct answer on this one, I think it's 1, -2.
That's all right.
Well, you're in now.
I just want you to
Because you said,
yourself, Jordan.
you said that answer a fraction of a millisecond before I got it myself. That took all the fun out of it.
Large test.
It's been Chris, don't worry about it. Hey, Chris, don't worry, I gotta get you
Ah, yes, I don't know how to do multiplication. There we go.
On that door.
I can't do multiple. Okay, yeah. I can't do multiplication.
Ah, there we go. Wait, now we're getting actual numbers.
Give it another. Okay.
Was it 1 -2?
Yeah, it's 1 -2.
Yes.
Wait.
Yep, 1 -2.
That's not
Actually, not first try.
Definitely didn't think 9 times 4 was 45.
Why would you think that's
What was it?
Okay.
I was getting 43 over 17. He said the order should be 1 -2. I'm like, oh yeah, I remember that.
You are smart.
Too loud, kids, too loud.
Chris, God's not supposed to make mistakes.
You're a fat door.
Did you say you're a fat door? You're one fat door. It's just a question I have myself. I'm sure that's how it hurt.
Mr. Milbrath, you know we're having that ACT prepping on Thursday again?
Probably this week.
We're not gonna be.
Yeah,
not this week.
Oh,
Yeah, I'm not gonna.
You might actually be back in time for that.
We're gonna be back for direction.
Alright, that's about all the time I can allot.
That's just too bad.
So back to it. You jump that 5 while over, what happens to sign?
It changes to negative.
Austin, you should be writing this down if you don't have it. Your hand runs math just as much as your brain does. What can be done with that x? I'm sorry, what can be done with that x value? Where can you put it?
Behind the 4, you got a time.
Hey, 1 minus 30.
Slow down. Alright, straight your property, right?
Yeah.
I'm glad that some of you guys are bored, I am. Just be patient. What'd you guys get for -20y plus 3y?
Negative 17.
A lot of kids today have gotten -23, not being careful. It's -17y. Instead of subtracting 36, what are you gonna do?
Add it.
Add it, you get 34. You're gonna divide out that -17. Y is -2. And now that you have y, plug it back in. Put it right there is where I put it. All right, that should give you 10 minus 9, which is 1. With a pair of 1 -2, just like I told you. And most of you got there. Some of you didn't. Please get there. All right, so that should be it for substitution method. And believe it or not, this is the fastest method. It's called the elimination method. It's got a lot of steps to it, but it's actually, substitution is kind of chaotic in its layout, and just you do stuff here, then you do stuff there, bring it back. Elimination method doesn't have that problem. Steps are to multiply one or both of the equations by a constant to obtain the same coefficients for one of the variables, add or subtract one equation from the other to eliminate a variable, and then substitute back in. If you did homework packet number 2, you'll probably be in better shape than those that didn't. This is solved using the elimination method. And step 1 says multiply one or both equations by a constant to obtain coefficients of the same number. You really got to decide if you want to go after x's or y's. Why'd you say x's? Smaller numbers. Nobody cares about the sign, it's about the size of the number. 3x and 6x. What's the smallest thing they both enter? 6 don't enter 3. 6. Change that top 3x into 6x. How do you change a 3x into 6x? Multiply by 2. It's not just the first thing. It's everything. You double everything. 2 times 3 is 6x. 2 times negative 7 is negative 14y. 2 times 10 is 20. Rewrite the other equation that you didn't modify right underneath it vertically. Step 2 says you can either add or subtract those things together. What do you want to do? Probably subtract. Because if you subtracted, what would disappear?
The
X's.
Oh.
Now, one thing I want to say is, don't be this kid.
I'm him.
What's the only thing that kid is going to take away? He's just going to take away 6x. You're subtracting a line. Wrap before you subtract. Maybe you get it right without wrapping, I don't know. But you wrap to remind yourself, because you kids you all have ADHD. You do something and you look at your phone and you go back to your math. I've watched you guys do it. Are you going to remember that you're supposed to take away the whole thing? Probably not. Wrap the thing to remind yourself that you're subtracting everything. Change that color so it's more apparent. That's a parentheses, not a 16. Now, what is 6x minus 6x?
0.
0. How about a negative 14 minus a negative 8? Negative 6. Yep. I'm taking away a negative. What's taking away a negative? Adding. That's why I write before I subtract. 20 minus 8?
12.
12. Divide by a negative 6, your y value is negative 2. Now, what do you do with that thing?
Plug it in.
Plug it in. Pick an equation.
3.
Equation 3.
I mean the one with the 3.
One with the 3. Why you wear your headphones? Plug it in any equation. It does not matter which one. 9 out of 10 people, though, they always go for the first. Which is what they do. All right, what's negative 7 times negative 2?
Positive 14.
What are you going to do with that positive 14?
You're gonna subtract it from the 10.
I'll give you a negative 4. What's your x value?
Divide by 3.
Negative 4 thirds.
That's still the sign.
There's your repair, kids. All right, it's not slated as a U try. I'm just curious though if you can do it. So let's make it a U try. Want to multiply one or both equations by a constant so that when you add or subtract, you can eliminate either x or y. I gotta do the same thing. I want to turn them into the same thing. After school tutoring starts today, by the way. Subtract 2 and add subtract which is proportional. What's the positive from what's the negative?
So we used to know
But what are you subtracting? Yeah, that's right.
Looks to me like he's back. That door's tired. Poor fat door.
Yeah. Did you watch Take Down to New Zealand today?
It's the villains, the running back yesterday. That's why.
Isn't the funniest thing watching this red run out on the field for they gotta kick a field goal?
Okay, I need to stop and go over this one. I only got the 3 rows there to check your work. When I looked at this thing, I thought about X's. I 4 at the top and I 3 at the bottom because I knew what the outcome would be. I'd have 12x up top, negative 12x in the bottom. 12x minus 24y is 36. And negative 12x plus 21y is negative 48. Well, you don't have to subtract those from each other. Adam. Any x's?
No.
How many y's?
Negative 3.
36 minus 48. What's your y value? 4. And now that y is known, what do you do with it?
Plug it in.
Plug it in. Agreed, were you paying attention there? I did not have to subtract. I think you did something, you ended up doing subtraction.
I'm trying to get it.
Plug it back in, I'd go for the top equation. 3x minus 6 fours is 9. You add your 24, you get 33. And what's your x value?
11.
11. Or pair 11, 4. All right. There you go, kids. What's up next to your notes? Many or none? Nope. I was going to teach a lesson on this Monday, but I wasn't here, so I let IXL do it. So you need prereq skills. Prereq skills. Prereq skills go back to Algebra 1. They actually have to deal with classification too, which I'm not going to talk about today. There is a set of parallel lines. Does a system of parallel lines have solutions?
No.
No. Parallel lines never intersect. No solutions. Most of what you did in IXL did not deal with parallel lines. Did parallel lines even show up in IXL? I would have been surprised if they did. Most of what you did in IXL had one slanted line and another line. So lines with differing slopes, how many solutions? One. So different slopes equals one intersection, which equals one solution. So this talks about no solutions as parallel lines. Different slopes is one solution. That's what we've been doing so far. And the last thing to consider is something randomly weird that you won't even realize why it gets introduced until you take linear algebra in college, which you will not take unless you plan on being an engineer. Who in here is going to be either a math major or an engineer in the future? So none of you will actually understand why this is taught to you. There's a very weird situation. It makes no sense at this point in your life to talk about where you graph the same blasted thing twice. How many intersections? It's the many. Infinite intersections, infinite solutions. And here that would be the many solutions. There's your three cases that can happen. Last one, by the way, is classified as a dependent system. Ms. Garner ever talk to you about independent, dependent? You don't know? She was here for enough of this because most kids have remembered this lesson. All right, time to solve. You want to do substitution or elimination?
Elimination.
Thank you. Elimination's quicker. If you want to play the elimination game, what do you do to the top equation? Triple it. So if I triple the top equation, what does it become? Right? Are we going to have to add or subtract down? Oh, I better wrap. Always wrap before you subtract. Always wrap in a lot of things in life. It's very important. What is 3x minus 3x? 0x. How about a negative 6y minus another 6y? Negative 6y. There's no y. How about 12 minus 8? What's no x plus no y? 0. What a weird statement. This thing says 0 equals 4. True or false? It's false. That's the big deal. It's false. False statements imply no solution. The false statements are where you have parallel lines. That's what they are. That's what a false statement is. It's a system of parallel lines. Anybody need any explanation on any of that? All right, last one. Identifying systems with many or no solutions. You want to play the substitution or elimination game? Elimination. Always elimination. It's quicker. What's the smallest thing? 4 and 14 enter. 28. What do you multiply 4 by to become 28? 7. So 7 everything. What do you multiply a negative 14 by to become negative 28? 2. And you can leave it negative. It's okay if one of them is negative. So you multiply everything by 2. Come on, Allison, I gave you a pen. Do you want to add them together or subtract them? Add. You want to add. Because if you add, what happens to your x's and your y's and everything else? There are no x's. There are no y's. And there's a 0.
That would make, that's one solution.
No, that's true. And some of you guys are just guessing. You're saying it's infinite solutions.
No.
It's just one solution. True.
It is infinite solutions.
So on the test, you will say
Yeah.
true or infinite solutions.
Anyways, I want to explain to you why. I'm going to. Let's convert the equations into y equals mx plus b. So we'll start with 4x minus 10y equal to 8. What do you want to move to the right-hand side? So negative 10y is a negative 4x plus 8. What do you want to divide by? Y is going to be 4/10 of x, which I'll simplify in a minute, minus 8/10, which I'll simplify in just a minute. What's 4/10 reduced to? 2/5 minus 4/5. That's the first equation. Second equation, do the same thing. Add 14x. What are you going to divide by?
35.
So 14/35 of x minus 28/35. And I'll slow down and just hush for a second. Let everybody write down. Race 14 and 35. What enters both of them? 7. How many times 7 enter 14? 2. How about 35? There's your 2/5 x. What enters 28 and 35? Enters 28 4 times. 35 how many times? What's true about those things? It's the same line. Graphed how many times? Twice. That's why it's infinite solutions.
So with the answer, do you want it to be true or do you want it to be infinite?
Infinite solutions.
Can I only give you one or the other?
There's actually 3 choices. When you get x equals 2, that's one solution. When you get 0 equals 12, none. You get 0 equals 0, infinite.
When's the graph